In this video, we're going to solve a problem which appeared in the year 2016. It's a JEE advanced level problem. So let's go ahead and first try to understand the problem statement. So here it is given that we have a series, right, which contains that log of, right, B1, B2 and B100. And this series is an arithmetic progression with some given common difference, which is log 2. And also it is given that the series A1 to A101 is also in AP, okay? But there is a condition that both this term, right, the first term in some sense that A1 and B1 are equal, and also A51 and B51 are equal. Now, it is given that, right, that if we have defined S and T as the sum of, right, the series of the sum of B and A, then we need to find out, right, which is greater than either S is greater than T or A101 greater than B101 and so on, right? So therefore, we need to find out the bigger values, right, between S and T and 101 and B01. So that's the particular problem. So let's go ahead and solve it. So to solve this problem, first we consider the series in AP which contains that log terms, right? That log B1, B2, B101 are in AP, right? So therefore, right, we can identify, right, the common difference. So what is the common difference? The difference between the two consecutive terms. So that's why here we consider that log of Bi plus 1 minus log of Bi is equal to log of 2. That's the common difference. And here the value of I or index notation, right, is actually appear from 1 to 100. That's obvious. Now we need to apply the properties of logarithm. What's that? We know that log A minus log B is equal to log A by B. So therefore, it will be reduced to log Bi plus 1 divided by Bi is equal to L into or log 2. So now we can take the anti-logarithm both sides, or otherwise we can say that we can cancel log from both sides. We can say that Bi plus 1 and Bi are equal to 2. So therefore, it's imply that the ratios, right, that B2 and B1, B3, B2, and B101 and B100 are equal to 2. So it implies that the ratio of the two consecutive terms are equal. So therefore, we can say that B1 to 101 are actually in a geometric progression series with common ratio 2. And as it is in the geometric progression, so therefore we can consider the general term or nth term as Bn is equal to B1 and common ratio is 2, so 2 to the power n minus 1. Okay, so you obtain that Bn. Now why we obtain that? Because see that we need to find out, right, that B101, A10 and so on. So from here we can easily identify what is B101, so that only we can find the relation between A101 and B101. Okay, that's it. So now let's go ahead and find the general expansion for A series. Okay, let's go ahead. So now we go ahead and find B51 and B101. Why? Because these are required. This is given in the problem. So let's find out. So B51 is B1 2 to the power 50 and 101 is B1 2 to the power 100. That's obvious. Now go ahead and discuss about the AP series of A terms, right? So here given A1 to A101 are in AP, and we assume that a common difference is D. And here two conditions are need to be imposed. What's that? A1 equal to B1 and A51 is equal to B51. So therefore, right, we can apply, or if we take the relation A51 and B51 are equal, we can say A51 is equal to B1 to the power 50 because B51 is already obtained. So therefore, we can find out that, right, in the left hand side, wherever we have A51, we can apply the general formula of a AP series. So therefore, that can be rewritten as A1 plus 50D is equal to B1 2 to the power 50. Now we can find the value of the D or the common difference by solving this particular equation. Let's go ahead. So here we consider that B1 because A1 equal to B1 and therefore D is equal to 2 to the power 50 minus 1 divided by 50 multiplied by B1, which is very straightforward arithmetic calculation. Now we need to find also A101 because that's the only one thing is left except S and T values. So A101 is equal to A1 plus 100D. Just substitute the value of the common difference in the place of D. So therefore, by simple calculation, right, we can obtain the values of A101 in the form of a B1, right? And B1 we just keep alive. Okay. So 101 is A101 is equal to B1 2 to the power 51 minus 1. So now A101, B101 is already obtained. Now our job is to find out S and T separately. Let's go ahead. So now here we consider that S series, that S is equal to sum of A1 to A51 term, right? Now here, how many terms are there? 51 term. And what is the first term? A1. What is the last term? A51. So therefore, in the AP series formula, the summation of any term is equal to n by 2, A1 plus AN and AN. Okay, that's it. So therefore, here it is 51 by 2, A1 plus A51. Now we know the values of A1, which is B1, and A51 is equal to B1 2 to the power 50. So therefore, right, 2 to the power 50. So therefore, we can easily substitute that particular value. So therefore, it is 51 by 2 B1 plus B1 2 to the power 50. And if I take B1 values, right? So therefore, we can easily substitute that appropriate value. So we take B1 common and we multiply by 51 by 2. So actually, we are taking that 51 by 2 inside the bracket. And then after solving the calculation, we find out B1 is equal to 51 by 2 plus 51 into 2 to the power 49. And that's it. So you obtain the value of S. Now we go ahead and calculate the value of T. So T is a series which is the sum of B1 to B51 and it's an GP series. So therefore the sum will be B1, the first term, into the common ratio. The common ratio is 2. So therefore we can say 2 to the power 51 minus 1 by 2 minus 1, which gives me that B1 is multiplied by 2 to the power 51 minus 1. And that's it. So you obtain all the required values to solve or analyze the options now. So let's go ahead and try to analyze that which options are correct. Let's go ahead. Notice that we already obtained the value of S and T. Now we need to find out which is greater than either S or T. So that's why we need to find out the subtraction of S minus T, right? So that difference between S minus T. Let's go ahead. So here we consider the difference of S and minus T. Now see that here B1 is taken, can be taken common. So just take B1 common. And then, right, that 51 by 2 and 1 can be 53 by 2 and 2 to the power 51 can be written as 2 square into 2 to the power 49. So therefore, it can be written as 4 into 2 to the power 49. Now, if we subtract each other, we get it as 53 by 2, 47 into 2 to the power 49. Now, it is obvious that B1 is greater than 0, right? Why? Because see that it is given that BI is greater than 1. So S minus T is always be positive, right? So if S minus T is always be positive, so therefore we understand that here S should be greater than T. So therefore we obtain, right, the one options. Now we need to find out, right, the between A101 and B101, right, which is actually the higher value, right? That's it. That's the last step is remaining. Let's go ahead. Okay, so to find out, right, the difference between, right, that A101 and B101, which is higher, right? Here we go ahead with the ratio thing, right? So here we take the ratio of B101 and A101. Okay, so if we take the ratio, right, it's obviously it is 2 to the power 100 divided by 2 to the power 51 minus 1. Now it is obvious that, right, 2 to the power 100, right, is much bigger than 2 to the power 51 minus 1. Okay, so therefore we conclude that, right, in the ratio, right, that 2 to B101 and A101, the numerator is much higher value than the denominator. So therefore, this ratio should be greater than 1. And hence, B101 is greater than A101. So therefore, we can easily understand for this particular problem, option B is the correct choice. So therefore, for this particular problem, option B is the right choice. So that's it. Hope you understood the problem. It's a very easy problem. Only we have to solve all, or we have to calculate all the required entities step by step and then analyze it. Thank you.